Record. Okay, so what we want to do now is add to this model some initial count of people infected. There's a count initially infective parameter, and we want to actualize that. We want to have that many distinct individuals infected. We've seen that this is not the only way we could accomplish something kind of similar. We saw that previous way where we had a certain fraction, a certain proportion of the initial population infected, and we could use an initial state, an initial branch to divvy up the population. If each person flip a coin with the probability given by that proportion, and with random true being used, and if it's true, they go to the infection state. Otherwise, say they go to susceptible. We did that in a previous model. I want to teach you another one that is particularly well adapted when you have a count of people you want to get infected, and it allows you to infect just that number. Okay, it does have a little bit of extra sort of cruft to make this happen. I apologize for it, but what it does is very elegant and in a single line. It cuts to the heart of that. Okay, so we're going to create an initial infection event. And this, again, is a pattern. It's a particularly common pattern for initial infection if you only have one to infect. And it's intention revealing. Time was, and I've seen my share of quite a few AnyLogic models where people embedded the initial infection, sort of the actualizing of it, like make an initial infection happen in a poorly chosen place. So they'll put it like in person and in the initial code for person to kind of perform the infection. And that's not, sorry, in main, in main. So you would like put in place in sorry, it's agent actions right here on startup, like the agent like main comes into existence and you like send a message. Don't do it. It's like hiding it in a place people aren't going to find it. You're not going to be able to find it easily. It's just asking for trouble. You're not going to notice. Maybe you'll put the functionality somewhere else because you don't notice it's here or whatever, and you'll have a hard time locating it. So don't do that. You're inviting trouble. So what you want to do instead is you'll have in main an initial infection event. And look, if you're infecting a single person, you just send an initial infected message to a person from the population. And this is very easy to do. If you just want to do that, it's a point of some elegance. And I'm just going to follow my nose, but you could say, like, give me a random person from the population. Okay. And then I want to send a message to them. And so I want to do like send. And as I recall, there's like an exposed message, and I could like send it to a single person. It'll be something like that. That would be for a single person if you were just infecting one person. But then the question is, how do you generalize this for n people, for a count? And I'm going to show you how to do that in a way that's not brutal. It's a bit imperfect. Some of my students might be able to figure out that I did this, 10 years ago, 11 years ago. And the support for this sort of type of work is now much better in AnyLogic in general in Java. So maybe there's a even better way to do it. Then it required a little bit of kind of machinations. So here we go. We're going to, I'm going to put it in the chat. Okay, so what are we going to do? Well, look, you're going to pass a recipe for how to get the type of people you want to consider. And then you're going to get a set of distinct ones. And oh, sorry, Jeff. Sorry, that was supposed to be to everyone. Sorry. Here we go. Okay, look. So you're going to have a stream of things. These streams, like, they have a bunch of things you're going to do things with. Okay. You're going to have a stream. You're going to know how to generate a stream of people. If I ask you for one more, just say, you know how to generate. And the way you're going to generate is by taking a random person each time from the population. That's my way of like giving you want a set of people? You want to ask me anytime to, give me a set of different people? I can do that. Each time I'll just generate a random. Okay. And then I want to say, okay, wait, I want distinct ones. And then I want a count of initially infected. Count initially infected. That's how many I want. I want count initially infected distinct people. And for each of those people, I'm going to send them this exposed message. Okay. That's the idea of it. And there's only problem. I wrote this code like 10 years ago, maybe 11 years ago, and I called it count initially infected. Here I have to call it count initially infective. And count initially. Oh, I misspelled it there. And I said initially. It should be count initially infective. Okay. Yeah, there we go. Yeah, we could specify places on a specific location, but we need people there, and that's what we're going to be doing after lunch. We're going to put people at each place. And so yes, we could do that. There we go. So I corrected that. But that would be like we needed to have people at that time. And so we'd want to design an event to go off at that time. Oh, it's time to have the salmonella infection, or it's time to have the E. coli infection. It's time to have the VRE infection. Time to have the Klebsiella infection, or whatever. And then like it'll go off at that time, and it'll say like, hey, school, I want to infect this many of your people, infect them, or this fraction of your students. And then the students present to the infirmary. Okay. So there we go. So basically, this is a way of getting count initially infected distinct people from the population. And for each one, boom, it sends them an exposed message. That's rather pleasant. Rather pleasant. So that's good. Now, but there needs to be a way for infection to be transmitted between people. And right now there's actually not. There's no mechanism because we don't have people like realizing who's close to them, and infecting them on a regular basis. We'll do that after lunch. But first, I do want to do the other. Okay, so that's the initial infection, and that